And without further ado, I would like to call up our speakers for the first session for sustainable project delivery using geospatial and digital twin platforms. Concept of digitalization and sustainability in construction and development. We need to first understand and come to a consensus in terms of what constitutes and defines digitalization, and how can GIS and BIM together, and digital twin for that matter, can bring along the level of sustainability that we have in mind. Now, without further ado, I would like to introduce the speakers for this morning. We've got Ingo Simonis. He's the Chief Technology Officer for Open Geospatial Consortium in Germany. We've got Amr Raafat. He's the Vice President for VDC Technology, Windover Construction, USA. And we've got Pierre, Group Innovation Director for Antea Group, France. Gentlemen, a warm welcome. Thank you so much for taking your time and participating in today's discussion. Now, without further ado, I would request Amr, if you would like to take the stage and start your presentation.
Sure.
Yeah.
Thank you. The slides are in there. Good morning, everyone. It's exciting to be with you all today to share ideas and some of the work we've been doing.
No, that's fine.
Sure. No audio, it's just my audio. Thank you so much. So one of the key aspects of using BIM and digitizing the process to build is not only capturing the data. Capturing the data is something, but utilizing the data to make things is key to transform the way we build. And that's what we focus on solutions. And not look at geospatial data or construction technology as tools, but rather as solutions that can offer real solutions, technological or tech-based solutions that can offer real impact in the construction process to transform the way we build, to build better, safer, and offer clients great value in terms of cost savings and building greener, which is saving materials. So using drones, for example, to capture data with ground control points. It's more than an eye in the sky, more than taking pictures. We utilize the data we capture to make sure we do QA/QC overlays when we pour, say, pour the slabs for a large building, and you have all the pipes coming from the underground. It's a standard in our process is that we laser scan all the verticals and do a QA/QC overlay to make sure all the pipes and the underground will meet its intended location on the first floor. That's QA/QC, making sure there are no surprises on site. And that's one of the ways we use laser scan data on job sites. And how we collect this data, it's using drones with ground control points. We last year partnered with Autodesk and RCML, it's a robotic software company, to develop a robot, called Oliver, that can capture autonomous laser scanning and on job sites from point A to point B, which you will see here. By the way, this is the QA/QC process. So this is the robot we helped develop with Autodesk. It goes from point A to point B, scan autonomously. Our BIM team doesn't have to be in the New England cold weather, standing to scan each round for 14 minutes or so. It's married with a Faro scanner, and it goes from point A to point B to scan. And what it can actually do is that it can lay out utilities directly from Revit, lay out utilities and walls directly from the BIM data. One of the other ways we utilize is really, for years, we've been using BIM data to help visualize things. What we've been doing, actually, we did at the Autodesk Technology Center in Boston, use this data to create almost 1,000 trusses for that building in the Fuller site. It's almost 1,000 trusses in only 15 hours, using the data we have in the BIM, and use it in Fusion, in a fabrication, industrialized construction modeling. And in 15 hours, it can produce all these high-quality trusses with zero waste to create all these pieces efficiently and in the most green way. So using the data we capture can also go to industrialized construction, offsite construction, and the making of things. And we took a step farther in that, and each truss was made out of 8 pieces. So what you do with that on site to assemble them, we partnered with Hologram from Australia, and what we did is that we used a new software called Hologram. It's like assembling furniture without having to look outside of the task in hand to make sure we can assemble all those trusses with mixed reality in 3 days versus 7 days with only 1 person versus 3 people. So the key here is to really how we can combine all these different technologies, such as geospatial data we capture from laser scanning, drone mapping, and mix it with BIM and virtual reality and mixed reality, all these technology offerings to offer real solution-based that can really transform the way we build. And I'm excited to join Danielle and nice to meet you, to join this great discussion today. Thank you so much.
Thank you, Amr. Thank you for your quick round of presentation and introduction to the different type of technologies that you have within your organization and their application search. I would like to request Daniel to take the stage next and present.
Good morning, everyone. Thank you for this opportunity to be here and to have a word about a subject of interest for me, which is environmental digital twins in general, and also to talk about the program Junon in particular. I'm Daniel Pierre. I'm the Group Innovation Director of Antea Group, and I have prepared this presentation with Sébastien Debras from the BHIM, which is the French Geological Survey. I won't talk about 3D, I won't talk about technology. My presentation is more on methodology and how we are building environmental digital twins. Just a word about Antea Group. We are a Dutch engineering company worldwide, a bit more than 3,200 employees. You have our figure on the screen, and we are working in 4 major segments: water, infrastructure, environment, and urban planning. Of course, you understand that geospatial data is just a subject transverse to all those segments. I will complete the presentation of Antea Group by the description of my unit, which is the Research and Innovation Division, mostly based in France. You will see that with the different profile we have some expertise all along the value chain of environmental data, from sensoring, measurement, instrumentation, up to data scientists, and also some GIS specialists. You can see that in our figure, we have a strong culture of calculation and sensoring. So the main purpose of my presentation is the following one. Yesterday we were talking about sustainability. More and more sustainability is expected for cities. We have smart cities. Digital twins are going to become a lever to make sustainable cities more and more sustainable. I know there's IT guys in this room, so I will make very clear with loop if then else. My purpose is the following one. If the challenge is to empower sustainable cities to face the global change, then we need environmental digital twins with an ecosystemic approach. Without that, we are maybe not joining the objective, the overall objective, which is sustainability. What is environmental digital twin for us in our daily business? It's a digital model with all a part of physical or human environment, and we render it interactive and dynamic thanks to real-time series data. And we bring prediction, environmental prediction model by integrating artificial intelligence and sometimes coupling it with more classical modeling approach. In that case, we are gathering a lot of amounts of data, of course geospatial data, a lot of information to characterize human activity, industrial activity, statistic, of course field data, and a lot of laboratory data, chemical analysis, biological analysis, and of course The dynamic aspect of our digital twin is bring by real-time series data coming from a diversity, a lot of sensor on the field around the city. Then come the computation approach, where we will try to mix different technique by trying to have data-driven approach mixed with some more physical-based modeling. We're doing that because we try to optimize more and more our process of studies, and also because we're facing more and more complex situation with massive modeling system. And also, instead of having one-shot studies, we will try to have new services by delivering dynamic and interactive decision support to our clients. So when it comes, for example, to talk about what is the issue for a city, a sustainable city, regarding to water stress, for example, then we need to put the city in its environment. And if we're talking about water issue, then we definitely have to put the city into the watershed, the basin, which is bringing the water to it. So in that case, we will have to gather and characterize information, gather information to characterize the different water cycle in agriculture, in industry, in the city. To do so, we're using conceptual approach in accordance to the European Framework Directive, and we will gather information to describe what we call the driving forces. The driving forces is all the activity coming from humans, and we will also characterize the pressure. It could be the translation of those driving forces or measurement directly of certain pressure we put on the environment, on the state of the water. The state of the water will be also described, but a lot of chemical analysis, a lot of measurement, direct measurement on the river or on the groundwater system. And then we come to have also some description of the impact, measure, compute, model, different types of data. So we have, in that case, to face new challenges, such as multiple data provider, multiple data format, multiple data acquisition frequency. It's a big issue for us to handle those information and to build a basement with strong data to have a very strong digital twin. Nowadays, definitely information system on water are a pillar for a good governance of the waters issue. In order to come to description of the Genome program, I have first to describe you a particularity of the Orléans ecosystem concerning environmental data. On this slide, you have the different academics institute next to the University of Orléans. You have the BRGM, which is the French Geological Survey, beside the research activity. He will handle in his public mission the system Infoterre, which is all the data, the information system on groundwater, on all the information to describe the geological context. You have the same with INRAE, which is the Agronomy and Environmental National Institute, which is taking care about Infosol. Infosol, it's all the information system dedicated to the soil quality, agronomy, and so on. I won't describe all of them, but all around you have a consortium which is fully specialized on banking and using environmental data. In that frame, with the support of the Région Centre-Val de Loire and the European Union, we are building an environmental digital twin on the Loire-Brittany system. On the map, you can recognize in black the perimeter of the Région Centre-Val de Loire. We are a bit lower than Paris. In blue, you have the limits of the water table of the BOS system, which is the biggest in Europe. Thanks to this BOS water system, we have also the BOS agronomic region, which is the biggest area for crops in France and in Europe. We have a lot of environmental compartment exceptional, and we have all along the river, Loire River, different big metropolises such as Orléans, Tours, Angers, and Nantes. The different ambition we are facing, we already have some proof of concept on certain challenges. The following one, we will work on the challenge of water stress, pollution, erosion of biodiversity, and natural hazards. And to do so, we will monitor and gather the information to do the prediction of the quantity and the quality of water resource, the environmental quality, the evolution of the biodiversity, and also to prevent the risk and increase resilience. Here is just an example of the conceptual approach we have when we are having data-driven approach based on machine learning. On the beginning, on the left part of this slide, you see that we have to feed the model with a lot of data, predictive input data. We try to organize them with the conceptual approach I described before, and response target data that can be measured data or modelized data. This is one of the main ideas I wanted to develop in front of you is when we talk about environmental digital twin, IA is just the visible part of the iceberg, and most of the effort, 70% of the effort, is data preprocessing. Otherwise, especially when you have legacy data in your assets of information to run and have your data-driven approach, you will just show all the different methodology of measurement you had in between all those years. This is the Genome Partner. You have some academics such as INRAE, BRGM, University of Orléans, and Tours. And you have also two major companies, Antea Group and Atos, the ICT French company. And I will be pleased to come back in 1 or 2 years with new results and better demonstration of the different results we build all together within the Genome Partner. I thank you for your attention.
Thank you, Daniel. Thank you for the really insightful presentation in terms of both data management and project information management, as well as risk monitoring. I would like to introduce Ingo Simons.
All right. Thank you very much. Good morning, everyone. If you're feeling cold down there, you should come up here. It's 5 degrees warmer up here than when I was sitting down there. So just a motivation to join the discussion later on, right? So let me give you some perspective on the Open Geospatial Consortium perspective on the topic we are discussing here today. A couple of words about the OGC, for those of you you are not familiar with us. It's a member-driven organization, currently around 550 members from all the different disciplines, from the research and academia side to the industry to the governmental organizations. And it's driven by the idea to make all geospatial data fair, right? Findable, accessible, interoperable, and reusable. And in this way, it complements very nicely what we have seen already, right? The integration of all these different data streams and legacy data that we do have available with all the different processing tools and applications and mechanisms that are just coming up these days. How do we do that? Well, OGC is mostly known as a standardization organization, which it certainly is. But we have evolved over the last couple of years, so from a standards-centric organization towards a problem-solving organization. So we do lots of research and development work now as part of the innovation program. And there, lots of best practices, how to do things, how should profiles or specific standards look like are developed within the innovation program. One aspect that I would like to emphasize here is the holistic view, right? On the left-hand side, we have the real world, where we need to understand all the different scenarios, and in this particular session here, it's about the meeting point between geospatial and BIM. Then we do have all those different data sets, right? All those different containers that in the presentations, when you see the demos, that nicely feed all together and create something cool and astonishable. Well, in reality, right, we know how hard it is, and we have just heard from Danielle again, how hard it is to actually integrate all these data sets. Well, can we bring these into data spaces, right? Data spaces as a kind of a mechanism to have common semantics, common data formats and models so that we can integrate the data more easily. And then the question is, what digital technology and tools do we actually need to get to the next level? And that's on the right-hand side, right? This is the Earth system modeling, or the smart city modeling, or the digital twin modeling, however you want to call it, right? At the end of the day, it all boils down to the same principles that we need to address here. We need to make sure we can integrate data and we're not comparing apples and oranges. And then, once we have done so, then we can get to the next level, and that's where we strive the interface between science and policy. Enhanced interability, right? I don't expect you to read this, but let me walk you a little bit through the elements we have here. On the left-hand side, on the top left corner, right, modular conceptual models, that's what the red box reads. It's our conceptual models of the reality. And each one of us has a different conceptual model. That's just the nature of how our brain is structured and how the way we learn things from the very early days up to right now. We do have different conceptual models. We need to agree on something. Well, that's on the conceptual level challenging if we tackle spaces where two disciplines like geospatial and BIM actually meet, right? And then we see that all these conceptual models need to be converted into logical and then to implementation models or physical models, however you want to call them. That brings us to the level of the semantic interability, right? What is a wall, right? If I ask you what a wall is, we probably get 20 different descriptions. If I ask you what an event is, then we get probably as many descriptions as we have people in the room. Still, we need to integrate these things, right? And if I look at the typical BIM representation of a wall, three-dimensional element, if I look at the geospatial perspective, well, a wall is more kind of a topological element, right? It is kind of a border or a barrier, but doesn't have necessarily a volume attached to it. We need to understand all these things. And once we have standards available or data formats available, we need to understand what was used in which way. So we do have those digital twins, for example, for the environment. Well, there, the sampling procedures has a very large effect on the data itself. So if I want to use the data, I need to make sure I understand the sampling procedure. Which procedure was used? So ideally, I have data that links to all the metadata it needs to have as essential components so that everyone can understand what the data can be used for, right? So the linked data approach, where I can get from my data to the standards that have been used, or the description, the specifications that have been used to create it, to sample it, to process it. And all of these elements need to be integrated into the models that we see in those demonstrations. Chris Tucker gave us a very nice video yesterday, right? You see those gaming engine-like representation of buildings you can just put somewhere on the globe and within a kind of a almost virtual and kind of almost naturally looking environment, and you just turn them around and do funny things with them. We need to make sure that we gap the bridge between these virtual environments and the information that eventually leads to the construction, for example, of these buildings, right? And that is all a very big interability challenge that we are addressing in OGC, and we have just calling out for a new initiative where we would like to further investigate these borderline between the geospatial perspectives and the models and the description, the semantics being used, and the BIM side of things. And the question is, what kind of transition paths do we have, right? We do have so many systems in place. So if we look at digital twins, it's not that we can resample, remodel, recollect all the data. We do have very, very large legacy archives. There are tons of data already available. Yes, we do fly drones every day. Yes, there are, 6,000 satellites flying around and taking pictures and other type of data every day. But we do have all those legacy systems, right, that we have used in the past, that is the upper path here, from the conceptual model to the implementation model to the deployment mechanisms to the various customers. Now we are getting into a complete new space, right? The underlying architectures have changed. We are getting away from the heavy query languages and similar approaches towards a more web-centric, web-like perspective of the systems. There are lots of questions in all these bubbles we see here that are extremely important when we talk about the interface between geospatial perspective and a BIM perspective, right? Because we need to explore what the mechanisms are to convert our legacy systems, our existing systems, and bring them to the up-to-date level and modernize them so that we can easily integrate the different data sets, no matter if it was collected 10 years ago and it's part of a system that is operational for a couple of years, or if it is a new system that we are just building today. And with these words, I thank you very much for your attention. Looking forward for the discussion. Thank you.
Thank you, Ingo. Thank you for the really brief yet wonderful presentation in terms of both enhanced interoperability as well as the transition paths and how we have to convert the legacy system into a much more approachable data set. My first question for the day begins with sustainability itself. There are different forms of sustainability. I believe there are sustainability in data management itself. There are sustainable designs for the construction of project or your city development. There's also sustainability involved in terms of the post-project handover, in terms of your carbon emission or energy consumption. What do you believe is the role of digital twins in all these different forms of sustainability? I would like to start with Amr, and then we'll take it forward.
You are bringing up a great point about sustainability, and I view it in construction at Windover Construction as best practices. We view sustainability in material management, for example, like the example I talked about, creating trusses directly from BIM, using cold formed steel so we can reduce waste. You almost have no waste in material, and that's key. Yeah. But it's not only about waste management or saving materials, it's also about future use of buildings. So we use a lot of prefabrication, offsite construction, and when you create those boxes and those beautiful buildings in factory setting, you are actually reducing the waste of energy used on site, right. Especially in the New England weather, in the extreme weather, because you are not weather dependent. You can create high quality products and buildings in factory setting. And in the future, when we are deassembling those pieces, instead of demoing them, they can be deassembled and used somewhere else being recycled. So it's a future supporting a sustainable, more sustainable future use of for these buildings. So using prefabrication, using the data we use, also reducing waste. The example we talked about QA/QC, reducing rework. It's also more material involved. So if we utilize all this geospatial data very carefully, very accurately ahead of the process, it's always easier to move pipes between sand than concrete. Right. So time is critical, and using the data we capture from laser scan early can really help us save time and money.
Got it. Thank you, Amr. Daniel, yours is much more prevalent because you are in fact involved in environmental digital twin, and that has a lot to do with sustainable based outcomes. So what sort of sustainable outcomes are you able to reap through digital twin systems in environmental planning and management?
The concept of sustainability is not new. but what is new now is that maybe that we are facing physically the global change, but also I think thanks to geospatial infrastructure, thanks to digital twins, we are able to show things, to better show to the decisions maker high level, even to the citizen. We used to say that for water issue, you need to consider 3 scale, a very micro scale, meso and macro scale, and you will address differently those 3 levels. It's not the same information, but in all the case, instead of having, I will say, a once-shot study where you say with a big book that, I don't know, in 2020 and in 2030 the situation will be the following one, when you can see, when you can put on the table something more interactive, it's better to convince all the stakeholders.
Right. Ingo, your closing remarks on that question before I move on to a few more questions in terms of sustainability and what does OGC see as sustainability outcome in the first place?
Yeah, there are multiple dimensions to sustainability here. And if you look at the data dimension, then one of the key aspects is certainly that on the one side, the digital twins combine a much larger audience, which at least I have the hope that we can agree on more common models for the data, because they have usually a longer lifetime than all these we make up our own model developments that we see every day, repeatedly over and over. And the other aspect I would like to mention is we rarely use raw data as it is sampled by a sensor, right? I mean, the sensor is whatever, capturing some reflectance or speed of light or something like that. But what we're actually working with is often very heavily processed data. So we do have the raw data, we process it over multiple steps to analysis-ready data, which is still not what many decision makers require, right? They need some sort of information or decision-ready information. And within this process, we have so much artificial intelligence now these days. And the question is, can I reuse the data that I have processed last year, next year again? If I have forgotten how exactly the model was trained, which training data was used, what the applicability of that data to, or of the model itself to a new maybe location or temporal aspect, is it still usable? Right. And that is a question that at the moment is, I think, not sufficiently addressed, because everyone loves the AI tools, and then we have high hopes in these, and that's probably a, well, it's a very motivational sector, right? We can get lots out of it, but the question is it sustainable? And I think it can be, but we need to make sure it is sustainable by providing the appropriate metadata, even though metadata is boring, we know, but eventually it leads to more sustainability in terms of the data and its usage.
Thanks, Ingo. And that's an interesting perspective, because like reuse, applicability, and scalability of the data in itself can contribute to sustainable outcomes. I have this question for both Daniel and Ingo, and this has to do with the legacy data, because that featured in both your presentations. Like, what are the interim challenges that you face in terms of converting or modernizing this legacy data in the first place? The legacy data? The legacy data?
Legacy
yeah.
data, sorry.
Yeah. So what are the challenges that you face in terms of like modernizing or converting it right now, and how do you overcome these challenges with your own customized or indigenous solutions for that matter? Daniel, yeah.
Well, actually, I'm the founder historically of a company named GeoHide in 1998, and GeoHide became a full subsidiary of Antea Group in 2013. And the first job of GeoHide was data management. We were having both skill, business and IT skill, dealing with data, extract, transform, load processes, etc. It was not evident at the beginning, but the situation was that I was working for big public client. They were having a lot of data, without any metadata. And their question, it was the following one. Well, due to the regulation, we spend millions and millions euro on monitoring the water bodies, monitoring few compartment, environmental compartment. We are 15, 20 years later. We have a lot of amounts of data, but is my data available for some valuation on it?
Right.
And the job was first to structure, to go for quality check, quality audit, quality control on all those information, to document this information, to gather also all the, to also put, there is a lot of standardization initiative, the OJC, we have business also initiative. So all that subject was the initial subject when we came into the picture of digital twin, and it's a major subject.
Right. Ingo, your remarks on that, like the challenges that you face in terms of, because you were talking about enhanced data interoperability, and then you were talking about the conversion and modernizing of legacy data. A few words on that. Yeah.
Well, on the one side, we see that the legacy data, I mean, that has been modeled often in a very formal way as well, as we do today, right? A conceptual model, then an automatic or rule-based conversion into a platform-specific model, and that's what we use. On the other side, the data was modeled with the idea of storing it somewhere, making it available for local processing. Right. Today, we are switching this pattern, right? We talk about cloud processing. The applications themselves need to travel to where the data is physically stored because you cannot transfer all the data anymore. And the question is, does these still fit together very nicely? And I think they can, right? As long as we do have used some open and well-defined interfaces in the past. But there is a big opportunity here, and that is we now have a much better understanding of new mechanisms to deal with that data. So we have data models like in German development or zonal planning, for example. They have more than 1,000 tables in the relational database, right? Can we use the modern graph databases? Can we use document-centric databases to store this and to store it more efficiently and to access it more efficiently? I think there are lots of great opportunities here. So the legacy is not so much a burden as an opportunity, I think.
Great. Amr, I'll come back to you, and I'll pick from where Daniel had left in terms of quality check and quality assurance, because I overheard you in your presentation of using all these modern robotics. In fact, like, you know, that's sort of the nightmare come true for on-site jobs, but end of the day, it's still bound to happen. I mean, there's no going back. So how does these advanced form of technologies help you in making sure you reduce your reworks, you increase your returns by that, like, you know, reduce your wastage as well? And what is your experience in applying these robotic technologies and, like, you know, remote applications?
So it's been QA/QC, quality control, has been very instrumental in avoiding mistakes. So our job every day as a BIM team or technology team in construction is to have no surprises on site when we get there. So one of the ways we've been doing that is laser scanning, constant overlays between design models and what's being built on site, like foundation walls, making sure we do a lot at Windover for prefab and modular construction. So you have boxes and the prefabricated structures that's fabricated in a factory, and you have a podium or a steel going on site. So you want to make sure that when these pieces made in a factory miles away, when they get placed on that foundation walls, they will fit perfectly. Otherwise, it's a really big, big delay. So to do that, we laser scanned constantly what's being built in real time on site, and compare it in real time with what's being in the factory, communicate the most updated as-built dimensions, not the drawing dimension, as with a few inches there. That makes a big difference because it's a domino effect, right? If there is an inch in one of the foundation wall, it keeps adding, and then it's a big problem. So communication in real time has been instrumental, and the only way we can really do that is laser scan. Another aspect which you're bringing up about the data, which Ergo and Daniel was talking about. When we hand the project to the client, it's key. Now it's a standard. Before closing up ceilings and walls, we scan the as-built MEBs. So 10 years from now, the client doesn't have to be BIM expert to review the model or something. You just go to a web-based link and see what's behind the wall in room 107. So they can support the future facility maintenance. That's key to carry over this built data into the easy use for the client who is not an expert in using that.
Right. Perfect. That kind of circles back to what Ingo was saying in terms of data reuse and applicability over a period of time. Another interesting aspect that I had foreseen across a lot of your presentations is the monitoring and prediction of project outcomes, or for that matter, like simulation capabilities. Like what does future hold in terms of these simulation capabilities? Like, will it be able to allow us to understand the type of repair and maintenance works that will happen, let's say in 5 years' time, in 10 years' time, based on the wear and tear? If that is the case, how does the data architecture in the back end help accomplish that? Daniel, maybe you can take it.
I have an example of the added value on it's more than a proof of concept, because it's a project we have developed with the French Geological Survey. It's for coastal early warning overflow. Before, we were already working on that subject, of course, with physical-based model. First, we were trying to both characterize what we call the alea, the phenomenon, and after we were trying to transfer it into a risk. It was taking us something like 40 hours of computation to give you an idea of what is going to happen in 2-3 minutes.
All right.
By coupling physics-based system and learning, we are able to do real-time prediction, and also because we are not trying to define with a lot of accuracy the area, but we are directly focusing on the risk, the place where the people will have to go and protect themselves, the gymnasium, the stadium, the roads, where the fireman, the ambulance will have to drive, you know. So it's also another paradigm, it's another approach, and we are focusing actually on the real question, bringing a characterization of, with a lot of accuracy of the alea. Actually, it's a scientific issue. We are happy to do so, but the question of the decision maker was not the following one. Where do I have to, can I put my population over there? Is it the time I have to warn everybody? That's the real question.
That's perfect. Ingo, your remarks on that.
Well, I mean, simulation is one of the big things if we talk about adaptation to climate change, for example, right? What are the most efficient measures? We cannot afford them all, so we need to select. If we talk about simulation in the more environmental context, well, it's one of the key challenges right now is the integration of all these live data streams into the running simulation, right? So I want to know where the flooding takes place. I know the storm is coming from the sea, for example, but what are the current rain amounts coming down over land? What is the current load already of the soil? Do I have the same system in County A as I have in County B, which is usually not the case, right? So how can I integrate these two? What is my latest infrastructure data? If we talk about buildings, the situation is slightly different. If we build a new building and we can capture all that new data that we need to do these types of simulation you mentioned, right? What do I need to renew in 5 years' time, for example? Well, that may work, but most buildings are already here. Right? And we do just constant, renovation and maintenance. And sometimes we do have pretty good data, but We're just getting involved in a project in Germany around the former airport Tegel, which has been closed in May this year, right? The plans are sometimes in French because they are just well created after Second World War, right? And they are on a piece of paper. So how much simulation can we do there, right? And how much effort should we do to digitize these elements in a way that we can then do these simulations? But I think simulation and all those what-if scenarios are absolutely crucial to be addressed.
Amr, are there any what-if scenarios that you guys run in your organization before you establish a design or like before you go on the construction site? If that is the case, what sort of technologies or platforms that you use to do that?
The most popular one, which we use almost daily at Windover, is 4D simulation, 4D animations. We get the data, whether it's a drone model, and then we add all the design elements, whether the architect give us the model or we create the model from his PDFs. And then we start simulating these data and tell the story, obviously, with a timeline of how we're going to build the project in terms of logistics planning, safety planning. Basically, it's a storytelling from start, foundation, steel, building complete, and among that, especially in occupied spaces, you have a campus and you have occupied campus, and where the students will go during construction. It's really helpful to communicate to clients, trade partners, and subcontractors, as well as the project team, how we're going to approach the project. So you can scroll down and see how the project would look in spring 2021. We saw this very helpful in the planning and visualizing, not only to visualize, but also to help plan the project. And all this storytelling won't really happen without capturing the accurate data on site. So to make sure that this story will be as close as possible to what will really happen.
Right. I'll open the questions to the audience now, but before that, we are live streaming as well, and we are getting some questions from online. And this question is for you, Ingo. There is an online attendee who's asking when will CityGML 3.0 will get released? CityGML 3.0, when will it get released?
As we speak, I think.
As we speak,
If it hasn't already, before we spoke, then it will be within the next couple of days.
Right. Okay, thank you. Are there any questions from the audience before I close this session? Any questions at all? No? All right. Okay, thank you, gentlemen. Thank you so much for your time. I really appreciate that. I hope it was insightful and worthwhile for all your audience, both here and virtually. I appreciate you taking your time and traveling all the way here. Thank you so much.
Thank you.
Thank you.
Thank you.